Okay, welcome back to the second screencast for Unit 4 of Microeconomics. And here we are having thought quite a bit about how marginal revenue product and marginal factor cost work, and hopefully having understood how the wage taker model of perfectly competitive factor markets works. And now thinking a little bit more deeply about how monopsony works, and especially trying to figure out some of these slightly more tricky or advanced processes and how they affect or work on the monopsony graph. We'll pick up with a kind of a re-explanation of why labor supply slopes up, because that'll be pretty essential to figuring out what's going on with the minimum wage cases, probably the most challenging bit that you'll need to know about the monopsony graph. So scrolling down here a little bit, I have summarized what I think is the same labor supply function that we used in part 1 of this screencast. The explanation that used to be over there is still, tucked on the side there. But what I did is sort of say at what quantities of labor correlate with which wage rates. Now, the relationship between these two first columns on this table would establish our labor supply curve. In other words, if the wage is 4, there's 4 people willing to work. If the wage is 1, there's 1 person willing to work. This is probably about the simplest labor supply function we could come up with. It's just L equals W. Every time you raise the wage rate by $1, you get 1 more worker who's willing to work. And to put this just one more way, we're saying that there's 1 worker who has a reservation wage of $1. Nobody's willing to work for less than $1. There are 3 workers who have reservation wages of $3 or less. There's one that has a reservation wage of exactly 3, and then there's another one that has a reservation wage of 2, and one that has a reservation wage of 1. So basically the idea here is that if the firm wants to hire 4 workers, it needs to consult this table and say, well, I better pay a wage of $4, and then 4 workers will want to work. One will kind of be neutral between working at that wage, and then there'll be these other 3 who are being paid a little bit more than their reservation wage. But they certainly will want to work. Okay, and once again, we'll just reiterate the idea that the firm cannot wage discriminate. So here's this column, total factor cost. How would I generate this one? It's just if I hired 5 units of labor at $5 a piece, it would cost me $25 in total labor cost. And you can see on the far right-hand column, I've plotted sort of right in between the values of L, what would marginal factor cost be. Remember, marginal is what happens when I change the number of workers I employ. So as I employ that first worker, my total factor cost goes from 0 to 1 for an increase of 1. As I employ that second worker, my total factor cost goes from 1 to 4, so it's an increase of 3. As I employ the third worker, notice that wage is only 3, but the total factor cost is 5. As I employ that fourth worker, the wage is 4, but the total factor cost is 7. And as I employ the fifth worker, the wage is 5, but the marginal factor cost is 9. I may have said total factor cost for 7, but the total factor cost with 4 workers would be 16, and the marginal would be 7. So plotting these points along with L's that are maybe halfway in between these values, or at those values if you prefer, that's what helped us generate this steeper upsloping marginal factor cost line. And hopefully you're comfortable with the idea that the firm wants to maximize its profit by hiring the number of workers where MFC equals MRC, and that's MFC equals MRP, and that's right there at L star. And then here we have W star as the wage that they're willing to pay. They say, let's pay the lowest wage necessary to get L star people to show up to work. All right, so that's a kind of a re-explanation right in here of these top 3 things. What are things we need to be able to do? Well, what if MRP shifted? That shouldn't be the toughest thing. What if MRP shifted over here? Well, I think the firm would probably say, let's hire this many workers right here. Suppose I could lengthen that line a little bit, because that's the quantity where MRP now equals MFC. And then they're going to come and say, let me find where that quantity of workers intersects with the supply curve, and that's the wage I'll pay. So there you see how an increase in MRP, it functions a little bit like demand, But notice that the firm is operating at this point right now, which is not a point on MRP. So that obviously can't be their demand curve for labor. They don't really have one. Okay, so we're back to square one here, thinking a little bit. You could kind of repeat that process about MRP shifting left if you wanted to. How about if labor supply changed? Now, first of all, why would it? If the number of potential workers around changed, or if their reservation wages changed. So let's imagine if the labor pool increased, or if people were willing to work for lower wages than they previously had been willing to do. So here perhaps would be a rightward shift of supply, and then we would have a new marginal factor cost that was further to the right. And this is going to mean now that the firm will want to hire this quantity of workers right here. I'm looking from this point right there where the new MFC line meets the same old MRP line. And then the wage they would pay, whoops. Goodness gracious. Things went a little crazy on me there. Sorry. We're going to hire this quantity of workers, and we're going to pay this wage rate right here. So you can see an increase in labor supply caused L to move to the right, and now they operate at that point right there along the new labor supply curve. All right. Here we are back to square one again, and we'll think about, I encourage you to repeat that process with thinking about LS shifting to the left. We'll think about what if new firms were entering into the situation. I don't know if we could really show on the graph how just one new firm entering would, but if we had if immediately the industry became competitive, or if we wanted to compare, what would this monopsony be like as compared with a competitive industry? In a competitive industry, you wouldn't have this separate MFC, MRC line. And so that's where you would say, well, in the competitive industry, we're just going to go to where supply meets MRP. So that's sort of your basic X that goes next to the wage taker model. And that should be that level right there. Again, that's really what this looks like up here. So I suppose in the same way that they can ask about a competitive market and a monopoly, they could ask about a competitive labor market as contrasted with the monopsony. Okay, so those are a couple things that are not too difficult to do, but they reflect that you understand how the monopsony graph works. Now let's work on the most challenging one, which is what happens if we impose minimum wage. And the big idea is we're going to try to think about using the minimum wage in what might be a counterintuitive way. We're going to induce the firm to hire more than black L-star workers down here, which seems a little weird because by putting a minimum wage, you're forcing them to pay a wage that's higher than W star. And how will they respond by actually hiring more workers? Well, it'll depend a little bit on what wage we set. So first, let's think about taking that minimum wage. If we were going to put a minimum wage anywhere down here below W star, that's like telling the firm, hey, you can't pay less than that blue-gray line there. Well, they're already paying more than that. So that won't be an effective minimum wage. It won't go into effect. So really the only ones that it's worth thinking about are ones that start there, and actually anything above this is a minimum wage that would go into effect. So let's think about what would happen if we were to put that minimum wage, say, here. Now what happens is that changes this table a little bit for the firm, because now if they want to hire one worker, they can't get that worker for $1 anymore. Let's say that minimum wage is $3, for example. I don't know. If that minimum wage is $3, then what we're saying is if you want to hire one worker, your wage has to be $3. If you want to hire two workers, your wage has to be $3. If you want to hire three workers, your wage has to be $3. So how would total factor cost look? 3, 6, 9. How would marginal factor cost look? 3, 3, 3. Let's model that over here and think about what we can do. Well, we have this line right here. We could bring that over and say, okay, this is the firm's labor supply curve that they face with the minimum wage in place. And there it is. Now, why does it bend up? We said that was $3. Well, when they hire the first 3 workers, those people are willing to work for $3 an hour. If they want to hire a 4th worker, now they have to pay everybody $4 an hour. So The marginal factor cost of these first three the wage rate associated with it, 3, 3, 3, and now 4, and then 5, because there isn't a fourth and a fifth worker who are willing to show up for that minimum wage of $3 that we maybe hypothetically put in place there. Now that, of course, will change their marginal factor cost as well. And in fact, you heard me sort of saying that. The marginal factor cost of those first 3 workers is $3, $3, $3. But when we hire that 4th worker, that marginal factor cost is $7. Because now we have to pay the 4th worker $4, and we have to pay all 3 of the additional first 3 workers $1 extra each. So that's where we get to 7. And so the new MFC curve that the firm faces is going to be this dotted orange line, which has a vertical jump in the middle of it. But we needn't get all stressed about that. We can think for each worker, would we want to hire them or not? And of course, we hire that worker if MRP is greater than the orange dotted line, and we don't hire the worker if MFC is greater than MRP. In other words, if the orange line is above our MRP curve. So how many workers would the firm hire at that situation? Kind of pause the video and see if you can confirm real quick how many. I'll go ahead and slide in right there. That's how many they'd hire, and the wage would be the minimum wage. Let's play around with that. Let's see, you notice how that increased the number of workers the firm hires, L. We'll play around with that at a slightly different level as well here. Let's say that we put that minimum wage right here. Well, now the firm's labor supply curve looks like this, and their marginal factor cost curve is here, and then it jumps up straight up from that bend there, right up to here. What does that mean? Well, now they're going to hire this many workers. That's actually right there the most workers you could ever get that firm to hire. There's no minimum wage that would get them to hire more workers than this dotted line right here. Let's see why not. Okay, what if we put, I'm going to leave that gray line there because that's kind of a special one. That's the wage up until that point, from W star until that gray line. Any minimum wage and raising it will cause the firm to hire more and more and more workers, and the workers will get a higher wage rate. So let's see what happens now if we take this green line and we stick it somewhere in here. Now, the firm has, of course, a new labor supply curve, and it looks like this. How do you make that new labor supply curve? Follow the minimum wage all the way across until it hits the old labor supply curve, and then bend it up along that old labor supply curve. And then we have to do, what is their marginal factor cost curve going to look like? We come all the way across here until that bend point, and the bend point, when you do marginal factor cost, actually is where it jumps way up. So it would jump up right about there. Well, this spot right here is where marginal factor cost, the orange dotted line, equals marginal revenue product. So this is the quantity of workers that firm will hire. Notice it's still more than L star, but it's not as many as it was at that gray minimum wage area there. Let's try one more time. If I were to keep pushing that wage up a little bit, this is kind of an interesting special one. Anywhere between the blue-gray one and the green one, you notice as we keep jacking that wage up, the firm hires fewer and fewer workers, but it's still more than they would without a minimum wage in place at all. At this point, our labor supply curve, I have to estimate where it will bend, but maybe somewhere around right there is where it will bend. And that means our marginal factor cost curve is flat all the way until that point. And then this sucker jumps way up to a place I can't even put it, way up over here at the top of the screen. You can see there's maybe a little bit. But the point is we don't need that segment of the MFC curve because we can see where the orange dotted line meets MRP. MFC meets MRP right at L star. The green minimum wage is the highest one that the workers could negotiate for or that the legislature could pass that would leave all the previously employed L-star workers still working. They would all get a raise. No new people would get a job, but nobody's getting laid off. Let's go even a step further. What if we put that minimum wage above that green line right there? How about it's right here? If we do that, then labor supply is horizontal until somewhere way out here, wherever this SL black line would come up and meet that wage. It's way too far for me to even worry about, right? So that's the labor supply curve the firm faces. Now, what's their MFC look like? Well, it's horizontal for a really long distance. Somewhere at this quantity, it would stop being horizontal, and it would jump up to somewhere several inches above the top of the screen. But I don't need that part of the graph because I'm looking right here at this intersection point. And I'm going to see that this is the quantity the firm will hire if you put a minimum wage at the pink level. Why is that? Well, let's think about the MFC or MRC curve. That's the orange dotted line, and where it intersects MRP. And that will help you figure out this will be the amount of workers they hire, and the orange and pink and red horizontal lines will all represent the wage. The big idea when we use that minimum wage on a monopsony is that we're transforming them into a wage taker for a certain range of quantities. Wherever this ended up, think about the minimum wage at the blue line. The firm was now a wage taker for the first, I don't know, we'll say that was 8 workers. The first 8 workers they hire, they're behaving like a wage taker, which means that their labor supply curve's flat, and it means that their MFC, MRC curve is flat and the same line. They face that horizontal supply equals wage equals marginal factor cost equals marginal resource cost kind of line. All right, well, hopefully that was a little helpful on monopsony. And one thing I want to do for just a couple more minutes here before wrapping this video up is to turn to the other key question of the unit, which is what's the cheapest mix of inputs firms can use to produce their profit maximizing quantity. And there's 2 formulas here that work really nicely if you remember back to Unit 2 when we learned about marginal utility over price and the bang per buck formula. So these are basically versions of that for firms. And that was a rule that said the marginal utility I get for the last apple I buy divided by the price of apples should equal the marginal utility I get for the last orange I buy divided by the price of oranges. So the last dollar I spent on each kind of fruit should yield me the same number of satisfaction points. Well, for a firm, they're buyers, and they're buyers of lots of different things. I'll use examples of L and K for labor and capital, but this could apply to different types of capital and different types of labor. If I imagine myself running a pizzeria, I might buy 4 or 5 different types of workers. If I had delivery drivers and people who make pizzas and people who serve them to tables and people who are managers, I might have 5 or 6 different kinds of land that I buy. Some of it would be dough, and some of it would be cheese, and some of it would be tomato sauce, and some of it would be pepperoni or green peppers or whatever you put on your pizza. And I might have 4 or 5 different kinds of capital I could buy. I could buy more baking pans and baking trays to bake the pizza on. I could buy more pizza ovens. I could buy more computer equipment and a better phone system or more phone lines to enable us to take more orders at once, or I could buy a fancy new online ordering system or something like that. So we could make this more than just 2 fractions that are equal, but we'll go ahead and tackle it in a small form. So we're trying to answer the question of how can a firm produce a given quantity of output at the lowest cost possible? And we want to kind of keep in mind that if I wanted to make 37 units, I could make 37 units with a fancy automated system and 1 person that pushed the button and turned it on. And that would be a way of doing it with lots of capital and very little labor. Or I could make 37 pizzas by having lots of workers produce them individually by hand and bake them by hand. What I want to know is what's the cheapest way for me to make those 37 pizzas? Well, I would set the marginal benefit over the marginal cost for each of those things I buy. And this is a bit like saying what's the marginal utility of buying 1 more worker? How many more pizzas will I get if I buy that 1 more worker divided by the change in cost when I buy one more worker. Well, that should equal the number of pizzas I get from buying the last unit of capital over the marginal factor cost of capital. And what this really is it's just a lot like marginal utility over price equals marginal utility over price, but just for two different things the firm buys. If I were to multiply both numerators by the product price, then I might get a fraction that looks a little like this, where I say marginal revenue product of the last worker I hired over marginal factor cost of that worker equals marginal revenue product of the last machine I bought over the marginal factor cost of that machine. And the basic idea here is that the last dollar I spent on labor should have boosted my revenue the same amount as the last dollar I spent on capital. So in words, there it is, the last purchase of labor and the last purchase of capital the firm made should each have yielded the same increase in output per dollar and therefore the same increase in revenue per dollar. And this is just that bang per buck theorem. If you're going to spend dollars at the market, you want your dollars to give you as many utils as possible. And if the firm is going to spend dollars hiring workers and buying more capital, they want their dollar that they spend to boost their output, if you're looking at this version, to boost their revenue, if you're looking at this version, as much as possible. We could take it one step further in the case of the firm than we can of consumers, however, and the reason why is because with the firm, at least if we look at the right-hand version of this formula, we know that the numerators have the same units as the denominators. These numerators are measured in dollars, and so are the denominators. So unlike with consumers buying goods at the mall, where your utils measure your marginal utility and dollars measure the price, we can come down here and we can actually make this a slightly stronger statement. So if we want to know not just any quantity, but specifically the profit maximizing quantity, how do I know that I'm making the profit maximizing quantity at the lowest possible cost? Well, I take marginal revenue product of my last worker over marginal factor cost of my last worker and set it equal to marginal revenue product of capital over the marginal factor cost of capital, and then ensure that both fractions are equal to 1. What that'll mean is that the last dollar I spent on capital boosted my revenue by $1, and the last dollar I spent on labor boosted my revenue by $1 as well. And there you can see the last purchase of labor and the last purchase of capital the firm made should each have yielded exactly as much revenue as each generated in increased costs. So now I suppose in the same way we did for consumers, we can ask a couple of pesky what-if questions. And the first one might be, what if those fractions are unequal? What should the firm do? Well, if these fractions are unequal, or if these fractions are unequal, or if the ones below are unequal, what would you do in the case of marginal utility and price? Whichever fraction was greater, you would buy more of that thing. The marginal utility of that good would decrease, the price would stay the same, and the fraction would get smaller. In the meantime, you'd be buying less of the other one, and the marginal revenue or marginal utility of the other one would increase. So if my fraction over here for MRP of L over MFC of L is bigger than for capital, what that means is that I want to buy another worker and maybe a little bit less machinery. And then this fraction will increase and this fraction will decrease. If they're not equal, the last worker or the last machine that you bought is a better deal than the other one, and you need to keep doing the thing that's a better deal. What if those two are equal, but they're both greater than 1? Or I suppose both less than 1. If they're equal and they're both greater than 1, what that tells you is that the last dollar the firm spent on labor yielded more than $1 in added revenue. Well, that's great, but probably the firm should have bought even more labor. And if that's true also of capital, that pretty much tells you the firm should have bought more labor and more capital. In other words, they're not making as many units as they should. If these two are equal but they're greater than 1, it means you should make more units. If these two are equal and they're less than 1, it means you should make fewer units. And if they're not equal, well, then you could make that same output with a lower cost by doing a slightly different mix of labor and capital. Hopefully that's helpful, and hopefully your understanding that you got a couple units ago about marginal utility per dollar and the bang per buck theorem is something that you can leverage, because this is almost exactly the same thing but for a firm. And firms don't buy apples and bananas, so we have different subscripts. And firms don't experience utils, but they do have revenue and they do have marginal product. And firms don't pay price, they instead incur marginal factor cost. So that hopefully helps explain to you a little bit about why those formulas are different. Thanks very much.